Nonetheless, the important thing is that force, we have learned about the different characteristics of the force. Also, force is a vector quantity. Then we learned that the SI unit of force is Newton. SI unit of force is Newton. Talking about, do magnets also exert a push or pull? Yes, they also exert a push or pull. It depends upon the type of poles that are brought close to each other. Right now, like the unlike poles would be attracting, like poles would be repelling each other. North or the south pole repels each other. Then we were learning about the characteristics of the force in the previous class. So what we had learned, that force will always bring some change in the state of the object. It can bring the object from rest to motion or from rest to motion. Like this object was in a state of rest. Now it can be moved with the application of some force on it. Okay, so when two forces will be acting in the same direction, so we have learned the net resultant force in that object will be the sum of the two forces. Like here in this case, just 1 minute. Yeah, give me a moment. Actually, there's some issue with the pen here. I will have to connect it to the charger. So what we are seeing, that let us say that there are two boys here. One of them is applying a force of 20 Newton. Another one is applying a force of 55 Newton. So the net force acting on the object here will be 20 plus 55 Newton, that is 75 Newton here. Getting it now? So when two force is acting in the same direction, the net force will be the sum of the individual forces here. So F net here will be F1 plus F2. If this one is applying F1, this one is applying F2. That is 20 Newton plus 55 Newton. So the net force acting on this object is 75 Newton, and it will be moving in the left direction. That is one thing. But when the two forces will be acting in the opposite direction, so there what we have learned, that the net force will be the difference of the two forces. Like one is 10 Newton, another one is also 10 Newton. So thereby the net force is 0 here. F1 minus F2 is 0 here. And if the magnitude of these two forces are equal, then thereby that is the case of a balanced force. The forces becomes balanced, and hereby the body will not be moving. But let us say if one of them were to apply a force with greater magnitude, let us say one of them applies a force of 20 Newton. So then the object will be moving. So the net resultant force on it will be in the 10 Newton in the left direction. Okay, no? So this body will experience a force of 10 Newton in the left direction. So that will not be the case of the unbalanced force. And we are able to move, different objects are able to show movement because of unbalanced forces. Okay, now a car moving on a road, or even you walking on a road, it is because of unbalanced force. As we know that when we are walking on a road, what we are doing, we are basically pushing the ground back. Now what do you do, that you push the ground back in order to be able to walk on the ground, right? Whenever force comes into existence, either pulling will be taking place or either pushing. Right, while you're walking, you're not pulling the ground, but you're pushing the ground back, and that's how you're able to move forward. Although you don't get to see the ground moving back because of its gigantic size. So when you are able to walk on a road, there also, like, you will be pushing the ground backward and your body will be moving forward. So your body is applying a forward force of, let's say, 100 Newton, while you are pushing the ground with some force of 10 Newton. So because of this unbalanced force, you are able to walk on the ground. In fact, most of the things that we see around us moving, they are able to move because of the unbalanced force. Okay. Furthermore, I also defined the Newton, like why this Newton was taken as a unit of force. Okay, now, so where we learned that, say, if you were to be provided with an object of mass 1 kilogram, the mass of an object is 1 kilogram, and if I were required to accelerate this object of 1 kilogram with a speed of 1 meter per second square, with an acceleration of 1 meter per second square. So the amount of energy that I will be requiring to make this object accelerate at 1 meter per second square, that will be called as 1 Newton. Getting it, Ramiz and Ibrahim?
Yeah. Yes,
okay,
sir.
So this is the standard definition for Newton. Okay, now, in fact, for every SI unit that is used now, there is some reason behind using it. Okay, now like there is a definition for kilogram also. Kilogram is also defined. Getting it now? In the similar manner, other SI units also have a definition. Meter also has a definition in scientific terms. Got this now? So, like for
Yeah.
example, kilogram. For in order to understand that, there are some other terminologies which you will have to understand. Okay, that's why I'm not touching that topic. Furthermore, another characteristics of the force is that it can change the state of motion of an object. If it is moving, it can bring it to rest, or if it is already moving, it can increase its speed, or if it is moving, it can bring it into rest, and if it is in rest, then it can bring it into motion. Furthermore, when do we say that an object is in a position of movement? When do we say that an object is moving? So whenever we see that an object would be changing its position with a reference object, with a stationary object. Let's say we have a pole here. So we see that after 5 minutes, the position of this card changed from here to here. So with the changing time, its position is changing with respect to this pole that is being considered as an observing point here. Okay. So for a body to be called in a state of motion, we have to observe that it should be changing its place with time. That is one thing. Okay, now. So when the object starts moving, it means that its position is being changed with respect to an observation point. Okay. So that is just a definition of motion, not nothing to be confused in this. Okay. So this was also one of the characteristics of the force. Other characteristics of forces were that it can change the speed of the object also. If a given car is moving with a certain speed, by applying brakes, its speed will be reduced, or in fact, it can be brought to rest also, or even we can change the direction. So for example, there's a car that is moving on a straight road. By applying force, we can change its speed and even its direction. So at a given time, different effects can be observed in a given body. Like at the same time, its speed might be reduced. At the same time, its direction might be reduced, might be changed. So all the effects brought upon by a force can be seen at the same time. Okay, now. Let's say, for example, while taking a turn, this car meets with another car. There's an accident, so thereby its shape will also be changed. So another characteristic is that the force can change the shape and size of the given object also. It can change the shape of an object and the size of the object also. Okay, and all these changes can take place simultaneously at the one time. This type of force we had learned in the beginning, that there are two kind of forces. One is contact force, another one is a non-contact force. Whenever two bodies will be in physical contact with each other, so there the kind of force that will exist between them will be the contact force. Examples are muscular and the frictional force. In the case of non-contact force, here when two bodies are not in close contact, not in physical contact, but yet they will be experiencing some force between them. So that will be the case of non-contact force. Like you'll be learning about magnetic force, gravitational force, and the electrostatic force in this. Okay. So first we were learning about the muscular force in the class. In the batch, this was being discussed. So in the case of, yeah, Aisha is here. So in the case of the muscular force, huh? So in the case of muscular force, basically the muscular force is a force that is being applied by the body's muscles. Huh? So muscular force is the force that the body's muscles will apply when they will be contracting or relaxing. Okay, now when they will be contracting or relaxing. Suppose you pull some heavy weight. For example, let us say that you are pulling some heavy weight. Let us say that this is our arm, let us say, and this is the bicep muscle, and this is the tricep muscle. Okay, so when you will be lifting off some weight, for example, so thereby what will happen? The bicep muscles, it will be contracting. The biceps muscle, it will be contracting, while the triceps will be relaxing. This is biceps, which contracts, when we lift something heavy, and this is triceps, that will be relaxing at the time of lifting something heavy. So due to the contraction and relaxation of these two of these pair of muscles, we are able to lift something heavy. Or basically, movement between the bones is possible because of the movement of these bones here, of this muscles here. One of the muscle would be contracting, another one would be relaxing here. So while these muscles would be contracting and relaxing, they will be exerting some force, and that force will be called as muscular force. Are you guys getting it? Aisha, Ramiz, and Ibrahim, all of you turn your cameras on in the class. In fact, this simple thing we can do at in the class, like if you were to lift something heavy, if you were to lift dumbbell, so you will observe that your uh, biceps would be contracting, it will be increasing in size, isn't it, guys? And the triceps would be relaxing. Or say that when you take a dumbbell and when you stretch it out like this, so thereby the triceps muscles, it will be contracting at that time, and at that time your biceps would be relaxing. Getting at what I'm trying to say? So movement is always possible because of the contraction and relaxation of the muscles, and due to this contraction and relaxation of muscles, a force will be generated. That force is called as muscular force. So muscular force is the force that the muscles of our body will be exerting when they will be relaxing or contracting, and it's a type of contact force. Okay, it can be applied only when there's physical contact. So whatever kind of activity we do, for example, like walking, running, jumping, or even chewing the food. Okay, so all of these are examples of muscular force, not only by the humans, it is applied by the animals also. Like here, this bullock is pulling some weight. This is the tug of war. So in all these activities, muscular force is applied. Okay, now. So that is the case of the first contact type of force. Nothing too technical about that. Talking about another type of contact force, we had the case of frictional force. So frictional force always comes into action when two bodies will be in contact with each other, and one of the body will try to move over another, where the one body will try to move over another body. So that is the case of the frictional force. Few of the important properties we learned about the frictional force is that it comes into action because when we look at the surface of objects, so the surface of objects are not very smooth like this. They don't have a very smooth texture. It is because of the irregularities present between the surfaces of objects. What happens? These irregularities gets interlocked into each other. So that gives interlocking effect. That generates interlocking effect. Okay. And it is because of this interlocking effect between the irregular surfaces of objects that it becomes difficult for one object to be moved over another. Getting it? Suppose I have a book over here. So if I were to slide this book over another one, it will be experiencing some friction because of the irregularities on the surface of these two books here. The surface are not very smooth. But on the other hand, let us say that if I have taken to a very smooth surface, or let us say if I were to apply some oil on this, so it will become easy to slide one book over another because their friction is reduced. So the kind of force that is generated when two surfaces are in contact and they are being slide over one another, so that will be the frictional force. Also, we know that, say that you are pushing this given object A in the right direction. So due to the irregularity between their surface, the friction that is applied here, it acts in the opposite direction. It is acting in the left direction while you are applying a force on it in the right direction. So friction always acts in a direction opposite to that of the applied force, or opposite to the movement of the body. Like even if this body starts to move, then also friction will be acting. It doesn't mean that friction has been there is no more friction. Still friction will be occurring here. So friction will be always opposing the movement of the body. It always opposes the movement of the body and acts in a direction opposite to the applied force and to the motion of the body. There are different factors that affects it. These forces are mainly affected by the surface texture and the amount of force is which is impelling them together. So say that if the surface have a very rough texture like this, so thereby if the texture is very rough, so thereby the friction will be more. Or if the surface area in contact is more, let us say that surface area in contact is more, so thereby more friction will be generated. Or say that if I were to push them with a greater force, earlier let us say I was pushing it with a force of 10 Newton, so so this object was, the force of friction was also, let us say, 10 Newton. But say that now I am pushing it with a force of 50 Newton, so thereby the frictional force also increases to 50 Newton. Getting it, guys, what I'm trying to say? Okay.
Yes, sir.
So, but there may come a time that, let us say, the frictional force has reached maximum. Okay, no? Let us say the maximum frictional force that will be offered by this object will be 50 Newton. But let us say after that, if I were to apply a force of 55 Newton, then the body will come in a state of motion. It will now start to move. So that's all about the frictional force, and frictional force will be occurring between two solid objects, and it will occur between two liquid and two a gaseous medium, and between a solid and a liquid medium, or between a solid and a gaseous medium also. What do you mean to say that? I basically mean to say that I have a solid object. So frictional force exists between two solid objects also. Okay. Frictional force will be occurring between two gaseous object also, and it will be occurring between two different liquid mediums also. Furthermore, it can occur between a solid and a gaseous medium, or between a liquid medium also. Okay, these are few basic things. Okay, like within the oceans also there will be friction between the different layers of the water that will be moving. Friction will be generated there. Between the different layers of the atmosphere, there also friction will be generated. Okay, between two solid objects, friction is generated. Or when an aircraft is moving in the air, so there that solid aircraft is like friction that is generated there. It is because of that solid aircraft moving in the gaseous medium. Or take the example of submarine. So there that solid submarine is moving in the water, so there also friction is generated. Talking about the air resistance, friction in the case of air. So air resistance is the force acting on an object that is moving through the air. Okay, that is will be moving through the air in the opposite direction. Take for example this aircraft. It is moving in this direction, while the air resistance is acting in an opposite direction. Okay, so air tries to resist its movement in the air. It tries to slow it down. Okay, now it tries to slow it down. So what basically happens, as the aircraft would be moving in the air, so it will be colliding with the air molecules. Say that these are air molecules with which the surface of the airplane will be colliding with, and because of that, friction will be generated. I take the example of this parachute skydiving here. So hereby, the person opens up the parachute, so thereby, due to the air resistance, the speed at which the person was falling towards the ground has been reduced because of the air resistance here. Getting it? If he were not to open the parachute, he would have fall towards the ground and would have died. But as he opened the parachute, so thereby what happened? Because of the air resistance, thereby what happened? Because of the air resistance, he will be coming slowly to the ground. So there, what happens? Say that these are the air molecules, and these air molecules will be colliding with the parachute and will be slowing down its movement. So that is the case of the air resistance. Okay, now. So hope it should be clear.
Yes,
So in
sir.
the case of air resistance, we have learned that whenever an object will be moving or will be flying in the air, it will be experiencing a force called as air resistance. It will be experiencing a force called as air resistance. So that was the case of the contact forces. Okay, now, so if you guys have any confusions in contact force, please let me know. Yes.
No doubts.
Okay. What were the types of contact force we have learned about?
Muscular, gravitational,
Gravitational is not a contact force,
contact, and muscular,
and
frictional.
frictional force. Okay, now that is one thing. Now let us learn about the non-contact force here. So talking about the non-contact forces, so non-contact forces are the forces that do not require physical interaction. Like we have gravitational, magnetic, and electrostatic force, where the force will be acting between the objects without making direct contact between them, without there being a direct contact between them. Okay, now, so that is the case of the non-contact force. Okay, so let us first talk. Let us first of all talk about the gravitational force. Okay, so talking about gravitational force. So gravitational force, it's a attractive force that is applied between two given objects. Okay, no, whenever there are two given objects in the universe, so a force of attraction acts between them. That is called as gravitational force. Say you have any two given object. So you have any two given objects. So these two objects will be attracting each other. But you'd be asking why these two objects don't seem to be moving towards each other, because of their insignificant size. They are very small. But say if one of them were to be a planet, if one of them were to be a planet in and another object were to be in its gravitational field, so thereby it will be experiencing the force of attraction towards this. I mean to say that every object that we see in the universe, they will be attracting each other, whether that object will be of 1 kilogram or whether that object be of 1,000 tons. But the thing is that we don't get to see them moving towards each other. Do we ever get to see two and random objects just starts to move towards each other? No. Getting it, Ibrahim, Ramiz, and Aisha.
Yeah.
So this gravitational force, it's a property of the universe. Every object would be attracting or will be exerting a force of attraction on every other object. Okay, now. So say on a piece of table, I have just 1 minute. I have different objects on my table. In fact, all those objects would be pulling each other, will be exerting a force of attraction on each other. Okay. You see that? Just 1 minute. So say that on a table, let us say that there are different objects. All these objects would be pulling each other, would be attracting each other with a force of attraction. But we don't get to see any of them attract each other. We don't get to see that this object A moves towards B or B moves towards C. But let us say that if in this, if I were to have planet here, let us say there's a planet here. So planet as compared to other objects is very big in size. Its mass is huge. It has a very big size and its mass is huge. So thereby, the force of attraction that this planet will be having is much, much more than other objects. That's why you will get to see that these other objects will be moving towards this planet here. Take the case of the Earth. So we humans, our mass and our size in comparison to Earth is insignificant, right?
Yeah.
Okay, now say the another important concept here is that when you take a jump, when you are jumping on Earth, so here the Earth is also pulling you towards itself while you have also pulled the Earth towards itself. When you jump on Earth, the Earth also pulls you towards its center while your body also is pulling the Earth. Getting this what I'm trying to say? What happens when we take a jump? Our earth pulls us while we also pull the earth. The force of attraction happens here. Okay, no? But the
Yeah.
movement of the earth is completely negligible here. When we jump on earth, we indeed pull the earth slightly as it pulls us also down. But earth is so much more massive than us that the movement of the earth is almost negligible. Okay, no? But what we notice that rather than the earth moving towards us, we get pulled towards the ground. Okay, now we get pulled back to the ground due to the earth's much gravitational pull. The earth has a stronger gravitational pull because of its massive size. So what I was trying to explain you guys that this gravitational force, it's a property of universe. It will occur between every two objects. It's not necessary that every object will be moving. The only situation where one object will move over another, that one of the object has to be very massive in size. Hope it should be clear. In case of earth, we say that the attractive force that the body experiences towards the center of the earth is called the force of gravity due to earth. Okay, so say that any object, let us say we have thrown a ball in the sky. So this ball will be attracted towards the earth and it will be experiencing a force of attraction towards the center of the earth and that force will be called as force of gravity due to earth. Okay, now that will be called as force of gravity. Okay, others who were present in the class, you guys tell me about the force of gravity magnitude. What was the magnitude of the force of gravity of earth?
9.2 Newton.
9.8
Oh, 9.8.
9.8 meter per second square. Okay, now so force of gravity is 9.8 meter per second square. So this is the force with which we'll be getting pulled towards the earth or any given object that is thrown into the air. So hope this much should be clear. All right. Okay. And keep this thing in mind that this property is exhibited by every object present in the universe and not only on the earth. Okay, so all the planets, the moons, and even the suns, they have a gravitational force of their own. And the bigger the object, bigger will be the magnitude of the gravitational force. Okay. Now, if you were to look at the force of gravity of moon, it is 1/6 of Earth. Okay, now it's 1/6 of the Earth. Why is it so? That the force of gravity of moon is 1/6. Why force of gravity of moon is 1/6 of Earth?
The moon is smaller than the earth.
Exactly. Because of its small mass, because of its smaller mass. So it has a gravity that is about 1/6 of the Earth's gravity. So a very interesting thing we observe that if a person will be weighing 180 pound on Earth, so on moon, let us say a person weighs 180 pound on Earth. So you know that on moon, that same person would be weighing 30 pounds. 30 pounds. Here I'm talking about the weight, not the mass. Mass means the actual component in the body which can't be changed. But weight means that the force with you are pulled towards the earth or pulled towards any other planet. So your weight will be different. Your weight on earth is different. Your weight on any other planet or any other, let's say, asteroid, it will be different. Because weight is basically the force with which you are pulled towards the center of that planet. While your mass will be same. Let's say you weigh 70 kilogram. So on moon also you'll be weighing 70 kilogram. I mean to say, talking about the mass, so your mass would be same. But when you talk about your weight, the weight will be changing because weight is the force with which you are attracted towards the center of that body. And since the force with which you are attracted towards the center of the body, it changes. On Earth, it's 9.8. On Moon, it is different. It's about 1.3 meter per second square. So hope this much should be clear. Okay. Then on what factor the gravitational force will depend? If the bodies are far away from each other, so then by the force of gravitation between them will decrease. The force of attraction will decrease. Just let me take one slide here. Let us try to understand this with an example. Say that this is Earth and this is the field of gravity of Earth. Field of gravity. Let us say that there's any object here. Let us say that there's an asteroid here. There is an asteroid. And there is another asteroid B here. Asteroid A, asteroid B. This is the given distance between the Earth's center. This is the center of the Earth. And this is the distance between the center of the Earth and this asteroid A. And this one is the distance between the center of the Earth and the asteroid B. Now, which one of them will be pulled towards the Earth? Which one of them will be experiencing A? What about others? A. Aisha, what about you? That is A. Why is it so? Because the distance here is adequate. It is lying in the field of gravity of Earth right now. So this object being in the field of gravity, okay, it is in the adequate distance, so thereby it experiences the force of attraction. While asteroid B is much away, it is outside the field of gravity, so it will not be experiencing the force of attraction by the Earth. Now let us take another asteroid. That, let us say there's another asteroid C. Now out of asteroid A and C, out of these two asteroids, namely A and C, which one of them will be experiencing more force of attraction?
Asteroid C.
What about others? Ibrahim and Aisha?
A.
That is C, obviously, no? Because of the distance. The distance here is less. So one of the major factor that will determines the gravitational force that will exist between two objects will be the distance. Okay, now? So as the distance decreases, thereby the force of gravity will increase. Okay, now? And as the distance increases, the force of gravity will decrease. Hope that is clear.
Yes.
So gravitational force depends on distance between the two bodies. Okay. Next thing is that let us say that you have two objects here. Let us take the case of the sun and the earth. We see that there's a huge difference between mass of earth and sun. There's a huge difference between the mass of the earth and the sun right now. Like if you were to look at the mass of the sun, so sun's mass is about 3,33,000 times the mass of the earth. Whatever is the mass of the earth, the mass of the sun is about 3,33,000 times. Getting it, guys? If you were to take 6 like 5.9 multiplied with 10 and put 24 zeros along with 10, so that is the mass of earth. The average mass calculated of the earth is 5.9 times 10 to the power 24 kilogram. And if you were to multiply it to 3.33 lakh times now, that is the average calculated mass of the sun. So obviously here the sun is having a huge mass, so the gravitational force of sun will be more because of its mass. So mass also determines the measurement of the gravitational force. Got this now? So mass of the given body, higher the mass, higher will be its force of attraction, higher will be the gravitational force. Is that much clear? I hope it should be clear.
Yes.
Then we have the case of electrostatic force. So in the electrostatic force, in the case of electrostatic force, what we get to see that uh, in this what will basically happen, like there are two bodies. One of them might be charged, another one might be uncharged, or both of them will be charged. So because of the charge between two bodies, a force of attraction will occur between them, and that will be called as electrostatic force. So when you have two charged bodies, one is positive, one is another one is could be negative, or both of them could be positive or negative. So thereby, a force of attraction or repulsion will take place between them. So so that will be called as electrostatic force. And when does an object become charged? An object is said to become charged when, like we know that any given object is made up of atoms. Atoms are the structural unit of everything that we see around us. Furthermore, atoms also contain some particles in it called as protons and neutrons in it. Right? Atoms have electrons, protons, and neutrons in it. Getting it? So when the number of electron changes in an atom, so then it is said to be charged. Later on, you'll be learning about it in more detail, but as of now, just let me tell you, if the number of electron changes in a given atom, so thereby it becomes charged. It might either become positively charged if it loses the electron, and it might become negatively charged if it gains the electron. Say there is an atom here, and if it gains electron, so this becomes negatively charged. Getting it? Or say you have an atom, if loses electron, if it loses the electron, then it becomes positively charged. So that is how this positive and negative charge comes on a body because of the loss or the gain of the electron. If it gains electron, it becomes negatively, or if it loses electron, then it becomes positively charged. That is one thing. Furthermore, when we look at the term electrostatic, the term electrostatic is made up of two words. It is made up of two words. One is electro, that is referred to as electricity. Another one is the static, that means something that is in a state of that is in a state of rest. So this electrostatic force will come into action because of charges being at rest, meaning that charges are not moving from one place to another. Charges will remain on that body, but because of the polarity of charges, because of the opposite or the like charges, a force of attraction takes place. Okay. So this electrostatic force, what we are learning, it's a non-contact force, which means that it can pull or push an object without even touching them, and it will be caused. It will be caused when two objects will be having opposite charge, or they might be having like charge, or one of the object may be charged, and the one may not be charged. Let me give some examples to you guys. Say, for example, you have a silk cloth, and you have taken a glass rod. You have taken a glass rod. What happens when we rub silk cloth with a glass rod? When we rub silk cloth with a glass rod, what happens? The glass rod acquires positive charges here. It acquires positive charges, and the silk cloth becomes negatively charged. It becomes negatively charged. So when a glass rod is being rubbed with the silk cloth, we observe that the glass rod acquires a positive charge, while the silk cloth it acquires a negative charge. Okay, now why? Here, because the electrons have moved from the glass rod to the silk cloth. The electrons have moved from the glass rod to the silk cloth. That's what I have told you moments ago. When an object would be losing the electron, it becomes positively charged. When an object will be gaining electron, it becomes negatively charged. Okay. So this is a phenomena that occurs due to charging due to friction when two objects are rubbed against each other. Okay. Now what we are going to do? Let us bring this silk cloth, or just let us bring this glass rod to tiny pieces of paper or tiny pieces of polythene, we might observe some attraction between them. You might observe some attraction between them. Getting it? Or just take a plastic ruler. We take a plastic ruler, and when we rub it against our hair, when it is rubbed against our hair, so it acquires charges, it becomes charged, and it starts to attract tiny pieces of paper. So are the papers and ruler here in contact? No, they still being not in contact. A force of attraction happens between them because of charges on them. So that is the case of electrostatic force. It's a force of attraction or repulsion experienced by a charged body from another charged body in the same vicinity. That is called as electrostatic force. So in the same vicinity, meaning that it has to be close by to the another object. If it is kept too away, if it is, let us say, if I were to place the, here I have the plastic ruler, and here are the paper pieces of paper. So attraction is not going to take place. It has to be in the same vicinity. It has to be here. Then only the attraction will be possible. So that is the case of electrostatic force. Okay, now. So force, or in simple terms, we can define it as the force exerted by a charged particle. Force exerted by a charged particle. That is what electrostatic force is. Also, we know that like charges would be repelling each other, while unlike charges would be attracting each other. So that's all about the electrostatic force. If there's any question in it, please let me know. Yes?
No question.
Okay, then. Talking about the magnetic force. So magnetic force also has two nature. One is attraction, another one is repulsion, right? So what basically happens in the case of magnet now? Magnets basically have two poles. One is north, another one is south pole. Also, we know that magnets are basically the ends of the magnet where the force of attraction or repulsion is maximum. How do we get to know that? We simply take a piece of paper, place a bar magnet in it, place a bar magnet in this, and sprinkle some iron fillings in it. Just sprinkle some iron fillings. These are small iron fillings. Just sprinkle it on it. So what we observe, like after you'll be tapping on the sheet of paper, not just tap on the sheet of paper. So you will observe that all the iron fillings will align themselves along the end of the magnet like this. They get aligned along the end of the magnets like this. So thereby it confirms that the ends of the magnets have highest magnetic force. Okay, now the magnetic strength is maximum at the ends of the magnet. So that is called as the pole of the magnet. And pole is of two types. One is north, another one is south pole. So the force that will be exerted by a magnetic object is simply called as magnetic force. And when like poles would be placed against each other like this, these two like poles are placed alongside each other like this. So they will be repelling each other, or they will rotate like this. You might have seen that when two magnets with like poles will be placed alongside each other like this, so they will be simply rotating like this. They'll be simply moving away from each other like this because they will be pushing each other. While opposite poles, like one that is north, another one that is south, will be always attracting each other. That is, they basically pull themselves towards each other. Okay, now. So magnetic force is basically attraction or repulsion that arises because of the like or unlike poles. So is that clear?
Yes.
Okay, no, nothing too technical about it. So that is the thing. Then we have one more type of force. Usually you might not have studied, but let me just tell you about the nuclear force. So nuclear force arises inside the atoms. Nuclear force would be arising inside the atom. Okay, now, like, why, if you were to look at a given atom, this is the structure of an atom. This is where the electrons are present. I mean, let me just draw on a structure. Okay, then you have this structure, this particle, and that is electron. These are the electrons. And this is the diagram of a atom. Okay. So when we look at the structure of atom, an atom has some subatomic particle inside it. Like you have proton, neutron, and electron. P here represents proton, and here is for neutron. Now, proton and neutron are found inside the center of an atom, and this center of an atom is called as nucleus. What do we call them, Aisha? That is nucleus. Now, there's a force that keeps proton and neutron intact. There's a force that acts between the particles inside this nucleus, meaning that there's a force that will be existing between the neutrons and between the protons, and between the proton and neutron also, meaning that, I mean to say that a proton and neutron, they will be attracting each other. Two protons, they will also be attracting each other. Two neutrons, they will also be attracting each other. So it is because of the force between all the particles inside this nucleus that an atom will be existing, and it is an attractive force because of which this nucleus will stay intact. So it's the force that keeps the nucleus intact by overcoming the enormous repulsive force between positive protons. Now what we know that the protons are positive, proton is positive, neutrons are having zero charge. So positive, positive, and neutrons have zero charge. So the thing is that we know that like charges, there will be a repulsion between them now. If there is positive and positive charge, so they will be repelling each other. They will be pushing each other. But what we get to see that although there are proton in this, and protons should be repelling each other, but still what we get to see that there's a force called as nuclear force, which is more in magnitude as compared to the repulsive force between the protons. That is why the nucleus is intact, and this force is called as nuclear force. I mean to say that basically you have this atom here. Inside the atom, you have this nucleus, and in nucleus, I have this two proton. Say that these are positive charges now, and they will be repelling each other, isn't it? Ramiz, Aisha, and Ibrahim. They will be pushing each other. So if they are pushing each other, the atom should break, then the nucleus should break, right? This is repulsive force. But why the atom is not breaking? Because there's a force of attraction also that occurs between these protons. And that is called as nuclear force. That is called as nuclear force. Is that clear to everyone?
Yes.
So one line statement for this is that it is the force that keeps the nucleus intact by overcoming the enormous repulsive force between positive particles, that is proton. So that was all about the force and different types of force. Okay, now before we continue with pressure, I would like to ask some questions from the force. Okay, so in the force, we have learned about basic things. First of all, you guys name the three different types of non-contact forces which we have learned.
Gravitational force,
Hmm?
magnetic force,
Okay. And
Is nuclear force a non-contact force?
nuclear force is usually not a non-contact force, I would say. Okay, no? It would be counted as a contact force. Nuclear force was, by the way, it was a special case. Okay, no? Don't put it in the category of the contact and non-contact force. Okay. So we had learned about magnetic force, then we had learned about the gravitational force, and the third one was electrostatic force. Okay. Okay, you guys also answer to me. If you were to look at the magnitude of this gravitational force, so on what factors the magnitude of gravitational force will depend? It will depend upon what factors?
The distance,
The distance, good, and
the mass and weight.
the not weight. It's better to say mass. Okay, no?
Okay.
Okay, that is one thing. Okay, also tell me about this thing also. Like, if the distance between two bodies is reducing, so thereby the um, gravitational force, will it increase or decrease?
It will increase.
It will increase. So it has an inverse relation. So it has an inverse relation, right?
Yeah.
Okay. Also say that when we get a plastic straw, say for example, we have taken a plastic straw. There's a plastic straw, and when it is rubbed with a synthetic cloth. Say that we have a synthetic cloth with which the plastic straw has been rubbed. So a plastic straw that is rubbed with a synthetic cloth, it attracts a plastic straw. It starts to attract another plastic straw. Okay, now it starts to attract a plastic straw. But if both of them are rubbed with a synthetic cloth, they repel each other.